This video is about trig equations in IB exam for number 7. Using the following for cosine A plus B and suitable double angle identities or any other appropriate trigonometric identity, prove the following triple angle identity. Cosine 3 theta equals 4 cosine cubed theta minus 3 cosine theta. So we have a cosine 3 theta. We can change it into cosine 2 theta plus theta. Then you can use this formula. For cosine A plus or minus B, that's a CCSS minus a plus. This is a plus or minus. So you can write down CC minus SS. We get cosine 2 theta, cosine theta, minus sine 2 theta, sine theta. For this double angle cosine 2 theta, because we want to get all cosine function, therefore you got to use this formula to replace this cosine 2 theta. That is 2 cosine square theta minus 1. Then times cosine theta minus sine 2 theta, we will change into 2 sine theta cosine theta, then times sine theta. This is the formula for sine 2 theta. So for distributive property, you will get 2 cosine cubed theta minus cosine theta minus 2 cosine theta sine square theta, because sine theta times sine theta. We do know for sine square theta, we can write down 1 minus cosine square theta. So let's do substitution. 2 cosine cubed theta minus cosine theta minus 2 cosine theta times 1 minus cosine square theta. Then we do distributive property. You will get 2 cosine cubed theta minus cosine theta minus 2 cosine theta plus 2 cosine cubed theta. Then we combine like terms. You will get these two like terms. We will have a 4 cosine cubed theta. These two are like terms, minus 3 cosine theta. So we finish proving for A. Now let's go to B. Find a similar expressions for sine 3 theta in terms of sine theta only. For sine 3 theta, we can write down sine 2 theta plus theta. We got to use this formula, that is SC plus or minus CS. So we have SC plus CS. You will get sine 2 theta cosine theta plus cosine 2 theta sine theta. Since our goal, we want to get sine theta only for sine 3 theta. Therefore, for cosine 2 theta, we got to use 1 minus 2 sine square theta. And sine 2 theta equals 2 sine theta cosine theta. So we get the 2 sine theta cosine theta, then cosine theta, plus 1 minus 2 sine square theta, then times sine theta. We will do distributive property here. You will get 2 sine theta cosine square theta, then plus sine theta minus 2 sine cubed theta. For this cosine square theta, we can change into 1 minus sine square theta, because our goal is a sine 3 theta in terms of sine theta. Therefore, you have 2 sine theta, 1 minus sine square theta, then plus sine theta, minus 2 sine cubed theta. Then we do distributive property for this. You will get 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. So we combine like terms. You will get, this is a 2 sine theta, that is a 3 sine theta. These two combine like terms, that will be minus 4 sine cubed theta. Let's go to C. Find the exact values of cosine theta that satisfy the equation cosine 3 theta equals 11 cosine square theta. First of all, we got to use this conclusion for cosine 3 theta to do the substitution. 4 cosine cubed theta minus 3 cosine theta equals 11 cosine square theta. Since this is a polynomial pattern equation, we will get equal 0 first. Therefore, we will move 11 cosine square theta to the left side. So we have 4 cosine cubed theta minus 3 cosine theta minus 11 cosine square theta. The common factor is a cosine theta. So we take cosine theta out. You will get 4 cosine square theta minus 11 cosine theta, then minus 3. I change this into ax squared plus bx plus c form. So we can get cosine theta equals 0, or 4 cosine square theta minus 11 cosine theta minus 3 equals 0. We got to use ninja x. For ax squared plus bx plus c, we do know a times c, this is b, over a. So we have 4 times negative 3 is negative 12. Here's negative 11 over 4 over 4. For negative 12, we can write down 1 times negative 12. Adding together is negative 11. So we have negative 12, here's 1. Reduce, you will get negative 3, here's 1. Then we know the variable is a cosine theta. Then we do bottom up to figure out the factoring. That will be cosine theta minus 3 times 4 cosine theta plus 1 equals 0. So we have cosine theta equals 3, or cosine theta equals negative 1 over 4. We know the range of cosine theta is a closed interval from negative 1 to 1. Cosine theta equals 3 is out of range. So we cross this out. We get cosine theta equals negative 1 over 4 and cosine theta equals 0. That's the solution for C. Let's go to D. Since we already figured out cosine theta equals 0, or cosine theta equals negative 1 over 4. x is greater than 0, less than pi. Cosine theta equals 0. This is quadrantal angles. We know here is 0, 1, undefined, CST. That's pi over 2. This is a 0, here's a pi. Therefore, this theta equals pi over 2. For cosine theta equals -1 over 4, theta equals inverse cosine of -1 over 4. That's all for D.